Welcome. We are in Unit 2, Lesson 2, Part 1, using rational and complex zeros. And complex zeros, remember, all that means we have an I in there, imaginary number for complex, to write polynomial equations. And this has a history of being pretty simple for the students here because it deals with a lot of algebra. Okay, a lot of algebra. So, example 1 here says a polynomial function has real coefficients, a leading coefficient of 1, and has the zeros -1, -2, and 5. Write a polynomial function of least degree in standard form. Okay, so I'm going to go over some steps here on how to do this, all right? And then we're going to practice it on our own here. First thing we need to do is we need to convert our zeros. And I say reverse booty cheek and T-bone process because that's what I say in my classroom, and the kids all giggle and they love it. And you know what? I don't care as long as they remember it. So the zeros they give us are -1, -2, and 5. So zeros are the same thing as roots, solutions, x-intercepts. It's the same thing. So the solutions to my polynomial would be -1, -2, and 5. Now, I say reverse booty cheek and T-bone. If I had some sort of parabola here, and what I'm about to write, I'll do this in green. What I'm about to write in green, just pay attention to it, because I want you to really understand this very simple concept. If I had x squared plus 8x plus 12 equals 0, and I had to solve that, I would, of course, factor this. Two numbers that multiply to 12 that add to 8. X plus 6, x plus 2 equals 0. And then I'd solve it. And this x would equal -6, and this x would equal -2. Now, I call this booty cheek and T-bone because I joke around and I say my sets of parentheses look like a booty cheek. Look like a booty. Those are booty cheeks. Then T-bone is just the T underneath. Okay, booty cheek and T-bone. Now you know my secret. Okay, so what they do here, okay, yes, I know I'm not writing in green anymore, but still, don't write this. They give us these, and they want us to put them back into their factors. Okay, so if I have -6, I know that came from the factor x plus 6. If I have -2, that should have come from the factor x plus 2. So that's all we're really doing for step 1. Okay, now we can continue the problem. So now you continue to follow me. Okay, what I did on the right side of the screen was just a kind of quick pro quo here. Reminder, this is what we're doing. Okay, so if I know -1 is a solution, that has to come from x plus 1 as a factor. If I know x minus 2 is a solution, that should come from x plus 2. And last but not least, if I have +5, that should come from x minus 5. All right? I have converted my zeros. Oh my God, highlighters. I've converted my zeros into factors. All right? That's what I did. Now, step 2 tells me, well, I should place the leading coefficient in front of them. They tell me my leading coefficient is 1. So I'm going to take x plus 1, my x plus 2, and my x minus 5, and I'm going to place that 1 right here. Because at the end, I need to multiply everything times my lead coefficient. Good thing for us, if we multiply anything times 1, it will remain itself. Okay? So now step 3 tells us. Now we got to start multiplying these things together, okay? I'm going to start step 3 right here. This is where step 3 starts. I've got to multiply my 3 parentheses or factors together, or my 3 cheeks. All right? And I will start by multiplying these two. You can start by multiplying the front two, but I'm going to do this. I'm going to FOIL these together. I know x times x is going to give me x squared. And I'm going to have minus 5x and plus 2x. So it'll be x squared minus 3x minus 10. That's what I get when I FOIL those two parentheses together. If you need to FOIL them off to the side, whatever, and write them, that's fine. This is what you should get. I still need to multiply x plus 1 into that. Okay? So I'm going to multiply my x into all three of those terms. So I've got x cubed, that's x times x squared, minus x times negative 3x is negative 3x squared. Okay. Then my last one, x times negative 10 is negative 10x. I still need to multiply my positive 1 into these. 1 times x squared is just x squared. And notice I'm lining up the terms. I'm lining up my like terms because when I add them, it's all going to be nice and even and lined up. Okay. 1 times negative 3x is just negative 3x. And 1 times negative 10 is negative 10. So now I just need to add all these things together. Okay, nothing for x cubed to combine with, so it's x cubed. A negative 3x squared and a positive 1x squared gives me negative 2x squareds. Negative 10 and negative 3x give me negative 13x minus 10. All right? Now, let's not forget, I still have to multiply them all times this 1. Okay, so technically, I got to take this whole thing and still distribute a 1 into it. And if we know anything about anything, we know that when we multiply 1 times any value, it will be itself. So when I multiply my 1 times all these things, it will still be x cubed minus 2x squared minus 13x minus 10. And that's already in standard form. We've already combined like terms. It says combine like terms. We did that here. We combined these two and got this. Okay? We combined these two and we got this. Okay? It's written in standard form. How come? Because we have our biggest exponent first. Our next biggest exponent is next. This is a 1, technically. That's x to the 1, right? And there are no x's here. So it's good. Now, if they want us to write a function, I kind of just think of that as an equation. An equation needs an equal sign. You can use y equals. You can use f of x equals. I'm going to use p of x. You would not get it wrong if you put y of x. You would not put it, you would not get it wrong if you put y equals. If you put f of x equals, it's fine. So how come I use p of x? I don't know. They're asking me for a polynomial. I just picked p because that's what polynomial begins with. That's not like a standard math thing or whatever. It's just a personal preference thing that I use. My polynomial with the variable of x, okay, my function p of x, is x cubed minus 2x squared minus 13x minus 10. Okay, example 2. I'm going to go through these a little bit quicker. Okay, if you want to pause this and do examples 2 and 3, go ahead. I would wait to do 4 because that's where an imaginary number or a complex number, comes into play. But if you want to try that, go ahead. But now's the time to pause the video and do just that because I am about to rip through these bad boys. Let's go. All right, we have the zeros, negative 2, negative 3, and positive 3. So x equals negative 2, negative 3, and positive 3. And a lead coefficient of negative 2. Okay, I'm just going to put lead coefficient is negative 2. You don't have to write that. It's just there for me. These should come from the factors x plus 2, x plus 3, and x minus 3. I'm going to FOIL these all together. These are a difference. These are you're multiplying conjugates together. I know when you FOIL those two together, you should end up with x squared minus 9. Okay? I still need to multiply in my x plus 2. And as a reminder, I still need to have a lead coefficient of negative 2. Okay, I'm going to wait till the end to multiply that in. Some people say, well, can I multiply my -2 in here and then multiply that in? You can, but then you're dealing with bigger numbers earlier. I like to get my whole polynomial done and then just multiply everything times -2. That's personal preference. Okay, let's do this. I'm going to FOIL my x in here and get x cubed. Okay, then we have -9x. Then we have, okay, plus 2x squared minus 9. I didn't line these up, and that's fine. You don't have to. Sometimes it works out nice. Sometimes it doesn't. And I still got to distribute this as -2 into all this. And I'm going to do that right now. I'll write it over here, -2x cubed plus 18x minus 4x squared plus 18. This looks weird. Let's see if I made a boo-boo. X cubed minus 9x. Yes, I did. Ho, ho, ho. This is what happens when you go fast. +2 times -9. It's not -9. It's a -18. Woo-hoo-hoo, look at me go. Which means -2 times -18 is positive 56. There you go. Now, the last thing I want to do is I'm going to write this in standard form. I'm going to write it nice and neat in the order it should be. They haven't really, did they tell us to write it in standard form? They did. Okay, so I have to do this to get the problem right now. My biggest term is -2x cubed. My next biggest term is -4x squared. After that, I get plus 18x. And last but not least, plus 36. There you go. Try not to go too fast, because when we go fast, that's when we make our mistakes. And I tell you what, I would rather you take the extra minute and get it right than go fast and get it wrong. Example 3, if the leading coefficient is 1. Okay, so my lead coefficient is 1. Well, let's make a nice equal sign there. What is the quadratic polynomial function? Quadratic means it's the lead term or degree is going to be x squared. You don't really need to know that. I mean, if you have 2 zeros, that's what you'll end up coming up with. But it's nice. They told us our quadratic should be x squared. If I come up with anything else in my answer than a degree 2, I've done it wrong. And the zeros are, oh, ugly. 1/2, it's a fraction, and 4. So let's do this. X equals 1/2 and 4, which means x minus 1/2, and that's fine. We're good. And x minus 4. And the lead coefficient is 1. That's beautiful, because 1 times anything is itself. Right? So let's FOIL this. X times x, x squared. X times -4, -4x. Okay. Half times x is -1/2 x. And then we got -1/2 times -4 is +2. Okay. So the only 2 things that I can combine here would be these 2. And don't forget, I got to multiply everything times 1, which is itself. So I have x squared minus 4.5 x plus 2. And if I multiply everything times 1, it's going to stay itself. So my equation is x squared minus 4.5 x plus 2. Word to the wise. If this were multiple choice on a final, they would not write your fraction like that. Okay? Please remember, if I have 4.1/2, I multiply 4 times 2, and then I add it to 1. 2 times 4 plus 1 is 8 plus 1, which is 9. So that's the same thing as saying 9 over 2. Multiple choice in the test would look like x squared minus 9 halves x plus 2. Let me go over this one more time. It's a very simple skill. All right? If I have 4 and 1 half, okay, that equals something over 2. What is it? I multiply these two numbers as I go up. 4 times 2 is 8. And then I add as I go back over. 8 plus 1 is 9. All right? There you go. So, short answer, this would be fine because they would say, if this is a short answer, the answer key for the people grading the test would say, this is the answer, anything this or equivalent. Technically, this is equivalent. You're fine if it's short answer. If it's multiple choice, though, I'm telling you, it's definitely going to look like this. So know the difference, okay? Number 4. Right, number 4 says, what is a cubic polynomial function with zeros 2, I, and negative I? Okay, cubic just means it's going to have a degree 3. It's going to have a degree 3. Thanks for letting us know that. They say nothing of a lead coefficient, so don't worry about it. They don't want to know a specific equation. Just give me one cubic polynomial function with the zeros 2, I, and negative I. So let's just do the work they're asking us for. Here are the zeros, all right? So if x equals 2, I, and negative I need to find out what factors they come from. Well, that's x minus 2. This one gives me x minus I, and this one gives me x plus I. Now, you see what's highlighted here? It says, note, complex roots always come in conjugate pairs. If you want to write this off to the side, you can. We don't need it to solve our equation because they give us the conjugate pairs. That means if I have one root that's 4i, I have to, even if it's not written, I have to know that I also have negative 4i as a root. Okay? If I have negative 13i as one root, I have to, even if they don't give it to me, I have to know that positive 13i is a root. If I have 1 minus I as a root, then 1 plus I is a root, because these are still conjugates, okay? So, because they gave us I, they also gave us negative I, because conjugate pairs have to be, they have to. They always, if you have a root, a solution that's imaginary, the conjugate is automatically also a root or a solution. And they just happen to give that to us. We didn't have to figure it out on our own. All right? But that might be coming up, hint, hint. So let's just do this the way we normally would. We're okay with I. We're okay with imaginary numbers and multiplying. If I do this, all right, x times x is x squared. X times I, well, that's just xi. Well, I mean, that wasn't that difficult. Okay, then we got negative I times x is negative xi. Negative I times positive I is negative I squared. The one thing that keeps coming back that you need to know I squared is negative 1. So let's clean this up, shall we? We have x squared. These cancel. Beautiful. Be careful here. We are subtracting I squared. I just don't make this negative 1. I just, okay, that's a negative 1, right? No, I squared is negative 1. I'm subtracting I squared, so I'm subtracting negative 1. That is really plus 1. If I had plus I squared, yeah, then there's plus a negative 1, which would be like minus 1. But you're subtracting. You are negating whatever I squared is. So if I squared is negative 1, don't forget we're negating it. Okay, so when we negate a negative, it's positive. Okay. Whew, that feels like the problem should be done, but don't forget we still need to multiply in x minus 2. That would give me x cubed. That would give me 1x minus 2x squared minus 2. So my polynomial function, and they told us it should be cubic, right? The biggest term, x cubed. Next biggest term, minus 2x squared. After that, plus 1x, and then minus 2. Boom. People ask me, why do you put different symbols there? Because if I see a symbol next to it, I know I've already put it into my equation. I'm not going to count it a second time. Just something I learned to do a long time ago. Makes things easy. All right, there we go. Example 5 tells us, or asks us the question, if you know two roots of a polynomial are 3i and negative 7i, list all the roots and state if it is linear, quadratic, cubic, or quartic. Now, don't let these four words closer to the end, I should say, throw you off. If it's linear, that just has a degree of 1, like x squared plus, ooh, yeah, I'll be okay. X minus 7, that's a line. That is linear. The degree is 1. It's the biggest exponent. A quadratic would mean I would have a degree of 2. The biggest term would be x squared. A cubic, the biggest term would be 3, like x cubed, so it is a degree 3. And quartic would be a degree 4. All right? That's all those means. And I'll write degree here and degree here. That means that would be the biggest exponent. Notice it doesn't tell us to write the equation of a line or a polynomial. We don't need to do that. You can, but that would be a lot of work. First, let's do the first task that they're asking us. Let's list all the roots, okay? So x equals, I know x equals 3i. I know x equals negative 7i, so maybe it's degree 2. There's 2 solutions, and however many solutions I have, that's my degree, hint, hint. Okay, but what did we just say right here? We said if we have imaginary or complex roots, the conjugates are also roots. They're also, even if they don't list them, they are testing you in this question to see if you know that. Okay, if 3i is a root, that means negative 3i is also a root. If negative 7i is a root, that means positive 7i is a root. Okay? So if I want to list all the roots, I kind of just did, but it's 3i, so I know negative 3i is a root. Negative 7i they give me, I know positive 7i has to be a root. And guess what? Your total roots, and when I say total, I mean both real and imaginary, always equals your degree. Okay, so this is a degree, therefore, those 3 dots mean therefore. It's a degree 4, which means this is quartic. We did not have to come up with the equation whatsoever. How easy was this? Okay, let me re-explain and re-go over this. List all the roots. Well, I know that if 3i is a root, negative 3i is, negative 7i is. Okay, there are 4 roots. That means degree 4. That means it's a quartic. That's literally all we had to do for this problem. You're welcome. We're done with this problem. Example 6. Find the general equation of a cubic equation. I like how they put the word equation in there twice. Find the general equation of the cubic equation having the roots 3, negative 2, and 1. If you want to do number 6, go right ahead. But this bottom thing, hold off here. Okay, unless you think you know what you want, you're doing, go ahead and do it. But if you want to pause and try and do number 6 and come up with the equation, go right ahead. I'm about to do it right now. Okay, so if my roots are 3, negative 2, and 1, that means it comes from the factors x minus 3, x plus 2, and x minus 1. All right, if I FOIL these two together, I know I should get x squared plus x minus 2. I still have to multiply in x minus 3. They mention nothing of a lead coefficient. Nada. So nothing. I don't have to worry about that. Okay? So all I've got to do is FOIL these. I have x cubed plus x squared minus 2x. And I got to do the same thing with my negative 3. Negative 3x squared, negative 3x plus 6. And when I combine everything, I get x cubed minus 2x squared minus 5x plus 6. That's my polynomial function. They tell me it should be cubic. It is. I have a degree of 3, and we're good to go. All right. So that's the first part. Easy. Easy. A lot of algebra. I told you there's going to be a lot of algebra today. But now, a little too far. Now they want us to find a specific equation. That means there's probably going to be some lead coefficient that I'm going to have to know, okay? So that the cubic equation that we just came up with right here passes through the point negative 112. That means x negative 1, y negative 12 has to work in my polynomial. They want me to come up with a specific equation where that point, that x and y value work. All right, well, I hope you know these are your x values, so I'm going to put a negative 1 into all of those. And I hope you know that this is the same thing as saying y. So I'm going to set it equal to negative 12. Negative 12 equals, I'm probably going to find a lead coefficient. I'm just going to call that A. 2, okay? Negative 1 cubed minus 2 times negative 1 squared minus 5 times negative 1 plus 6. All right? All I did was throw my negative 1 in for my x's, which were highlighted in yellow above. And if you are the type of person that needs to see visual, here you go for my x's, my negative 1s. For my y's, my negative 12. All right. So let's do this. Negative 1 cubed is still negative 1. Negative 1 squared is positive 1 times negative 2. That would be negative 2. Negative times a negative is positive 5 plus 6. So we have minus 3 plus 11. That would give me a positive 8. This whole thing is 8. 8 times A is just 8A equals negative 12. And I want to solve for A. So, bang. All right. So A equals negative 12 over 8, which reduces. 4 goes into both of them. Negative 3 halves. So my equation, if I wanted to specifically work for this point, is my lead coefficient has to be negative 3 halves times, okay, x cubed minus 2x squared minus 5x plus 6. This is fine enough. If it were multiple choice, maybe they distribute the negative 3 halves in. Okay, maybe they don't. Okay, that is absolutely A-okay. Good job. We are going to stop here. We're at the 29-minute mark. There's a couple more problems that we're going to do. There's this problem. There's a couple ones that require a calculator. Then there's some classwork homework that I am not going to go over because you're going to do it on your own. All right, we will see you next time for Unit 2, Lesson 2, Part 2. It's coming up next. See ya.